Dear students, welcome to the class. In the class, we are going to discuss one problem in diagonalization of the matrix by orthogonal transformation. See the problem. Diagonalize the following matrix by orthogonal transformation, where A equal to 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. See the solution. How to write the solution for this? To orthogonalize the matrix, first we have to find the eigenvalues. So to find eigenvalues, what is the characteristic equation here? The characteristic equation is mod A minus lambda I equal to 0. Actually the given matrix is 3 by 3 symmetric matrix. So therefore the characteristic equation shortcut form is lambda cube minus a1 lambda square plus a2 lambda minus a3 equal to 0. We have to find a1, a2, a3. Before we enter into the problem, first we have to see that whether the matrix is symmetric or not. Because to find or to diagonalize the matrix, first we have to check whether it is a symmetric matrix or not. So 3 minus 1 1, 3 minus 1 1, minus 1 5 minus 1, minus 1 5 minus 1, 1 minus 1 3, 1 minus 1 3. Therefore it is a symmetric square matrix. Is a symmetric matrix. Next we have to find the coefficients of this equation. So first we have to find a1. What is a1? Sum of diagonal elements of A. What is sum of the diagonal elements of A? 3 plus 5 plus 3, 11. Second, we have to find A2 value. What is A2 here? A2 is sum of minus of diagonal elements of A. So what is sum of minus of diagonal elements of A? See the first one diagonal element 3. The minor is, what is the minor? 5 minus 1 minus 1 3. Yes. Second one diagonal element is 5. The minus 3 1 1 3 plus. Third one diagonal element is 3. The minor is 3 minus 1 minus 1 5. What is the value of this? 15 minus 1 plus 9 minus 1 plus 15 minus 1. That is equal to 14 plus 14 plus 8. That means 28, 36. Next one is A3. A3 is the determinant of A. How to find the determinant of A? You can put that plus, minus, plus here. So take the 3. Write the determinant of 5 minus 1 minus 1 3. 15 minus 1. And then minus minus plus. Plus 1 into minus 1 minus 1 1 3 determinant minus 3 plus 1 plus 1 into last one determinant is 1 minus 5. So that is equal to 3 into 15, 14 42 minus 3 plus 1 minus 2 minus 2, it is minus 4. That is 36. So determinant of A is 36 here. Therefore, the characteristic equation of A is lambda cube minus A1 lambda square. That is A1 is 11. Then plus A2 lambda. What is plus A2? What is A2 here? Say that A2 is 36 plus 36 lambda. Finally, minus A3. That means minus 36 equal to 0. So after finding the characteristic equation, we have to find the eigenvalues. Write the heading to find eigenvalues. To find eigenvalues, already we know that how to find the eigenvalue for the cubic matrix. That is by using the synthetic division method. What is synthetic division method? We have to write the coefficients of lambda cube 1 minus 11, 36 minus 36. First we have to see that whether all the elements are equal to 0. Adding of all the elements of equal to 0, then the lambda is 1. Otherwise, if you are adding that alternate elements, then both are equal, then lambda equal to minus 1. Both are the case not here. Therefore, we go to the next one, choice 2. 0. First, arbitrarily put 0, adding that 1 and 0 plus 1 here, multiply the 2 and 1, 2. Then minus 9, adding this 2, then multiply this 2, minus 18. So plus 18 here, multiply this 2, you will get 36, 0. Therefore, one of the eigenvalue is lambda. Next we have to write that reduce one power of lambda here. Then we can write that lambda square minus 9 lambda plus 18 equal to 0. You know how to solve that quadratic equation. So when two elements are multiplied here, you will get 18. When you are adding the two elements, you will get that minus 9. So what are the two elements? The two elements are minus 6, minus 3. Adding this to minus 9, multiply this to, you will get 18. Therefore, lambda minus 6, lambda minus 3 equal to 0. Therefore, lambda equal to 6, 3. Therefore, the eigenvalues of A are 2, 3, 6. Next we are going to find that eigenvector. Write the heading to find eigenvector. To find the eigenvector, first we have to write the equation. In which equation you are going to substitute that value of lambda? A minus lambda I into x equal to 0. In this equation only we are going to substitute that value of lambda to find the eigenvector. So how to write this? A minus lambda I, subtract that minus lambda in the diagonal element. 3 minus lambda minus 1, 1 and then minus 1, 5 minus lambda minus 1, 1 minus 1, 3 minus lambda. When it is the 3 by 3 matrix, then we can take that x capital X equal to x1 to x3. Therefore, we can write that x1 0, 0, 0. Therefore, we can write that the eigenvector for the eigenvalue. First we have to take that case 1. What is case 1 here? Lambda equal to 2. Case 1 and lambda equal to 2. Then substituting the lambda equal to 2 here, 3 minus 2, 1, minus 1, 1, minus 1, 5 minus 2 is 3, minus 1, 1, minus 1, 3 minus 1 is, first value is 2, na? 3 minus 2 is 1. So, if you are substituting 2 here, 3 minus 2, 1, minus 1, 1, minus 1, 5 minus 2 is 3, minus 1, 1 minus 1, 1. To find the eigenvector, you have to take the non-identical rows. The non-identical rows. It is very easy to find that. x1, x2, x3. Once again write x1, x2. You have to write 5 columns. Then we have to write any 2 non-identical rows. What are the 2 non-identical rows? 1 and 3 are identical rows. No need to take. If you are taking the 2 identical rows, you will get the trivial solution. So non-identical rows are 1 minus 1, 1. 1 minus 1. Once again write the value. Minus 1, 3, minus 1. Minus 1, 3. To find x1, see that x1. To find x1, leave the x1 row, sorry, x1 column, find the determinant of this 2. That means 1 minus 3 minus 2. x2 by, leave the x2 column, find the determinant of this 2. That means minus 1 plus 1, 0. x3 is, leave the x3 column, then find the determinant of this 3 minus 1, 2. 3 minus 1, 2. So what is the eigenvector here? First eigenvector x1 equal to minus 1, 0. Okay, very easy to find the value here. To find the diagonalization of the matrix for the given real symmetric one. First you have to find the eigenvalue, then you have to find the eigenvector. Up to now we have found the one eigenvector. Next we have to find the 2 more eigenvectors for the values of 3 and 6. The continuation of the problem. We are finding the diagonal matrix or diagonalization of the matrix by using the orthogonal transformation. So what is the given matrix here? 3 minus 1, 1, minus 1, 5 minus 1, 1 minus 1, 3. Already we found the eigenvalues. 2, 3, 6. The eigenvector, first eigenvector x1 is minus 1, 0, 1. Now we continue with the case 2 and case 3. So what is case 2 here? Case 2 is when lambda equal to 3. When lambda equal to 3, we are going to form the matrix see here, we have to substitute that minus 3 here, minus 3, minus 3 in the diagonal. When we are substituting that minus 3, minus 3, minus 3 in the diagonal, then we will get that 0 minus 1, 1. And then second one is minus 1, 2 minus 1. Last one is 1 minus 1, 0. 1, 0. So find the eigenvector for this. We have to write the 5 columns. Take any 2 non-identical rows, either 1 and 2 or 2 and 3 or 1 and 3. all the 3 rows are not identical only. Any 2 row we can get. We can take 0, minus 1, 1, 0, minus 1, minus 1, 2, minus 1, minus 1, 2. So what is x1 here? To find x1, leave the x1 column, then multiply this, we will get that 1 minus 2 minus 1. x2, if you are leaving that x2, then we will get that minus 1. Or x3, you leave the x3 column, find the determinant of this 2, minus 1. So what is the eigenvector here? x2, 1, 1, 1. Second one eigenvector is 1, 1, 1. We go for the third one eigenvector. Case 3. Case 3 is when lambda equal to 6. When lambda equal to 6, we will get the matrix subtract with that minus 6 here, minus 3, minus 1, 1. Second one is minus 1. 5 minus 6 is minus 1, minus 1, 1 minus 1, 3 minus 6 is minus 3. To find that eigenvector for this, write x1, x2, x3, x1, x2, minus 3, minus 1, 1, minus 3, minus 1, minus 1, minus 1. Now, to find x1 value, leave the x1 column, find the determinant of these two columns. That is 1 plus 1, 2. x2. x2 is, leave the x2 column, find the determinant of this. Minus 1, minus 3, minus 4. x3. x3 is, leave the x3 column, then find the eigenvector, then find the value of this determinant. That means 3 minus 1. 3 minus 1 is 2. So what is x3 here? x3 equal to 1 minus 2, 1. 1 minus 2, 1. So what are the three eigenvectors here? x1. x1 is minus 1, 0, 1. x2 is, what is x1? x2 here 1, 1, 1. x3 is 1 minus 2, 1. Next we have to check that it is the orthogonal pairs or not. Then only you can verify that your eigenvectors are correct or wrong. Okay. So we have to check that orthogonal in pairs. How to check that? Orthogonal in pairs. That is x1 transpose x2 equal to x2 transpose x3 equal to x3 transpose x1 equal to 0. We have to prove that. What is that x1 transpose x2? x1 transpose x2 equal to, see that x1 transpose is minus 1, 0, 1. x2 is 1, 1, 1. That is equal to 1 minus 1, 0. Similarly, x2 transpose x3 equal to 1, 1, 1. 1 minus 2, 1. That is 1 minus 2 plus 1 equal to 0. Then we can prove that x3 transpose x1. x3 transpose is 1 minus 2 1. Then minus 1 0 1. That is equal to 0. Is it not? Now we can prove that the eigenvectors are orthogonal in pairs. Now we have to form the normalized model matrix. How to form the normalized model matrix? For that, first we have to form the normalized vector. How to find the normalized vector for this? For x1 normalized nx1. Normalized eigen vector x1. So that is equal to, how to find that? Minus 1 0 1. Write that minus 1 divided by square root of squaring of all the elements, sum of the squaring of all the elements. So minus 1 square 1 plus 0 square 0 plus 1 square 1. Similarly, put 0 here. Last one is 1 divided by square root of, how to find the normalized vector? How to find the normalized vector? All the elements divide with each elements. That means each of the elements of the eigenvector divide with the square root of sum of the squares of the elements. Sum of the squares of the elements. So minus 1 divided by square root of sum of the squares of element. 0 1 divided by minus 1 square, writing, see that 0 square plus 1 square. Same thing. Denominator for this column, denominator will not change. Denominator will not change. For all the elements of the denominator is same. So minus 1 by root 2, that is equal to minus 1 by root 2 0 1 by root 2. It is the first normalized vector. Similarly, second normalized vector we can write that. We can write the second normalized vector nx2. nx2. I am writing here. nx2. nx2 is 1 1 1 is that. So 1 by, same procedure we have to follow, 1 by root 3. 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 3. Third normalized vector. Third normalized vector, see that x3 is there. How to find that normalized vector for x3? That is equal to n x3 I am writing here. So 1 divided by 1 square plus 2 square 4 plus 1. That means root 6. Minus 2 by root 6, 1 by root 6. That is the third one, normalized vector. First normalized vector, second normalized vector, third normalized vector. Based on the three normalized vector, we have to form the normalized model matrix. From the normalized model matrix, we can diagonalize the problem. Continuation of the problem. First we found the eigenvalues for the given matrix 2 3 6. Then we are finding the eigenvectors minus 1 0 1 1 1 1 1 minus 2 1 respectively. Next we are forming the normalized model matrix. Normalized model matrix is, first we have to find the normalized vector. Then we have to, using the normalized vector to make the normalized model matrix. So what is the first one? Eigenvector minus 1 0 1. For that minus 1 0 1, what is the normalized model matrix? N. The normalized model matrix is denoted by capital N. And then see the first row, minus 1 by root 2 0 1 by root 2. So based on this vector. Second one is 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6 minus 2 by root 6, 1 by root 6. Already I explained how to find the normalized model matrix. Now, write the heading to diagonalize. To diagonalize the matrix, we have to use the one transformation. The name is called orthogonal transformation. Orthogonal transformation is n transpose AN. We have to prove that is equal to that diagonal matrix D. How to find that? First we have to compute that n transpose A. First we have to compute the n transpose A. So what is n transpose A here? N transpose A. First we have to write the n transpose. That means n is there. We have to change that row to column, column to row. So minus 1 by root 2 0, 1 by root 2, 1 by root 3, 1 by root 3, 1 by root 3, then 1 by root 6 minus 2 by root 6, 1 by root 6. Multiple with the matrix, given matrix A. So what is the matrix here? 3 minus 1, 1 minus 1, 5 minus 1, 1 minus 1. Now we multiply that, what you get? That is equal to, say, minus 3, 0 plus 1. Minus 1 by root 2 plus 0 plus 1 by root 2. Minus 3 by root. Minus 3 by root 2, 0, 1 by root 2. Second one. Second one, similarly if you are doing that second one, see that. Minus 1 plus 1, 0 minus 1, plus 1 and minus 1, 0 by root. Last one is, see that, minus 1, 0 plus 3, 2 by root. This is the first one. Second one is 3 minus 1, so we can write that 3 minus 1 plus 1 by root 3. Second one is minus 1 plus 5, then minus 1 by root 3. Last one, 1 minus 1 plus 3. Third row, first one, 3 plus 2 plus 1 by root 6. Second one is minus 1 and then minus 10, then minus 1 by root 6. Last value 1 plus 4 plus 3, 1 plus 2 plus 3, 1 plus 2 plus 3 by root 6. This one is what? N transpose A. Finally I am writing here N transpose A, N. So what is N transpose A? First you have to write that N transpose A, then multiple with N. So N transpose A is minus 3 plus 1 minus 2 by root 2. Second one is 0. Third one is 2 by root 2. Here 3 by root 3. 5 by root 3. 3 by root 3. Last one is 8 by 6 by root 6 minus 12 by root 6 and then 6 by root 6 multiple with n transpose. Multiple with n. So n transpose an. What is n here? This one. Minus 1 by root 2 0, 1 by root 2. Minus 1 by root 2 0, 1 by root 2, 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6, minus 2 by root 6, 1 by root 6. Multiply this two, you will get that n transpose an equal to, multiplying here. See that minus 2 minus 1 plus 2 plus 0 plus 2. 2 plus 2 by 2. Denominator 2 is there, root 2 is there, multiplication is plus 2. So second one, minus 2, 0 plus 2. So minus 2 by root 6 plus 2 by root 6. Third one, minus 2 by root 12 minus 2 by root 12 plus 0 and plus 2 by root 12. Root 12. So similarly we have to multiply the second and the third one. What you get? That is minus 3 by root 6 0 plus 3 by root 6. 3 by root 6. Second one is 3 by 3 plus 5 by 3 plus 3 by 3. 3 plus 5 plus 3 by 3. See here, it is minus 1 plus 5 minus 1, then it is not 5, it is 3 by root 3. So 3 plus 3 plus 3 by 3. Last one is 3 minus 6, 3. So 3 by root 18 minus 6 plus 3 by root 18 with the common denominator. Last one is, see that 6 by root 6 minus 6 0 plus 6 minus 6 plus 0 plus 6 by root 12. Second one is 6 plus 6 minus 12 plus 6 by root 18. 6 plus 6 minus 12 plus 6 by root 18. Final one is 6 plus 24 plus 6. 6 plus 24 plus 6 by 6. So finally n transpose A n, you can see that n transpose A n equal to 2 0 0 0 3 0 0 0 6. That is the diagonal matrix D. Okay, if you are doing the problem, if anywhere if you done that any plus or minus mistake in any steps, that the total problem will be wrong. Okay, so here also I have done one mistake here, minus 1 plus 5 minus 2, and I mistakenly I have written 5 here. Actually it is that 5 minus 2 3. So once you are not able to get that this diagonal element, diagonal matrix, please verify once again. So I hope that you are understanding the diagonalization of the matrix by orthogonal transformation. Next chapter is that quadratic form to canonical form. Okay, see you in the next class. Thank you.